Let's keep it rolling here. Our next piece of content, next up on EVCon, we're doing another one-on-one interview. This one with, and I see them both here right now, so let's bring them on, guys. Taylor Ogan is the CEO of Snowball Capital, and Tom Fennimore, the CFO of Luminar, one of, if not the biggest name in Lidar. Tom, Taylor, welcome to EVCon.
Thanks for having us, Spencer.
I'm going to see myself out, and Taylor, I'll let you take it away.
All right, thank you. So we've followed Luminar for many years now, and it's been a fascinating company to watch grow from a $50 million, $100 million, $200 million company just exiting stealth mode to now a $6 billion company that went public just last February or December, actually, under the ticker LAZR. Here we have Tom Fennimore, the CFO of Luminar. Tom joined Luminar in May of 2020. He was previously head of global automotive and co-head of the industrials group at Jefferies. Before that, he was at Goldman. And a bit about his company before he introduces more of it. Luminar is a global leader in autonomous vehicle solutions, namely Lidar. I'll let Tom explain what Lidar is for anyone that doesn't know, but Lidar is a necessary component for autonomous vehicles, these robotaxis that are ending up on a lot more streets these days. And the technology is recently being adopted by automakers that want ultra-safe cars with a human being still behind the wheel. Only a few years ago, Lidar cost between $25,000 to $30,000 per unit, but Luminar's brought the cost down to below $1,000, which is crazy, especially as it's going after an industry estimated to be worth over $150 billion by 2030. Luminar's partnerships include Volvo, SAIC, Audi, Pony AI, Daimler Trucks, Intel's Mobileye, Airbus. And you're going to start seeing Luminar's Iris Lidar come standard on the new Volvo electric XC90. So Tom, maybe you can give us a quick introduction to Luminar, what Lidar is and what differentiates your technology.
Sure, and Taylor, happy to do that. And let me start off first and kind of describe in a technical aspect, a brief technical aspect, what Lidar is. And so for those that are familiar with radar, radar uses radio waves to basically survey the surroundings in front of the actual unit. Lidar is similar, but instead of using radio waves, we use lasers or light waves. And there's three critical components in any Lidar. You actually have the laser, which basically emits the light. You then have some type of scanning mechanism, which basically then takes that light and uses it to direct it or scatter it to survey the surrounding in front of it. And then you have the receiver, which then captures the light that returns after bouncing off the multiple of objects in front of you. And what that allows you to do, a lot better than radar or any other sensor out there, including camera, is get a real ground truth of the surroundings in front of you. And so for our Lidar, we see at least 250 meters out. We have 120 degrees field of view horizontally and 30 degrees vertically. And so within that frame, you're able to get with high resolution, practically zero margin of error, a real-time 3D map of every object in front of you within that cone of visibility. So that's what Lidar is. Now for Luminar, the foundation of what we do is make Lidars. And I'll come back a sec and talk about why we believe we do this better than anybody else out there. But that's our foundation, and we'll talk more about this later. But on top of that, we also have just as many software engineers as we do hardware engineers. And while we have multiple series production wins with our Lidar hardware, we actually have multiple series production wins with our software as well. And so we're really building an ecosystem and a solution where our Lidar is the foundation. And what we want to do is become a major player, not only in Lidar, but in providing solutions and systems to enable autonomous vehicles. Now, going to a little bit more detail of what our Lidar is different, and our founder, Austin Russell, he started working on this when he was a teenager. And instead of buying off-the-shelf components, which mainly operate at a 905 wavelength, and 905 is just outside the visible light spectrum. And the easiest way to make a LiDAR is you buy 905 lasers, 905 receivers, you put them all together. We operate at 1550 wavelength. And so that's well outside the visible light spectrum. And the biggest difference between the two from a performance perspective is 905, and this is actually regulated by the FDA in the US. There's only so much power you can put through a 905 laser. And if you put too much through it, you can blind and do real damage to the human eye. You don't have those limitations at 1550. And because of that, you can effectively see further with a higher degree of resolution and do a better surveying of the area in front of you. Now, the downside of 1550 is historically been the cost. And in order to have a receiver that can receive the light at that spectrum, you need to use a very expensive material called InGas, where one wafer of InGas can cost almost $10,000. And what we've been able to do is build our receivers with only a fraction of the InGas on it. And with that, we're able to get the performance that is necessary at a cost that is only a few dollars per chip. And so we solve the cost equation with that breakthrough. There's two critical components you need to do that. One is you need great ASIC design. And 3 or 4 years ago, we bought a business called Black Forest Engineer. There's about 20 engineers globally that know how to do ASIC for InGas receivers, and they all now work for Luminar. And then you really need to know the secret sauce in terms of how to take that InGas and put it on a chip. And there's probably less than 10 engineers that can do that with the robustness and the strength that is needed. Some of our earliest versions of this several years ago, right? You can, if you actually put too much sensitivity on the receivers and you don't bind them the wrong way, they break. Earlier this year, we bought a company up in Boston called Optigration, which makes our receivers and chips. And so we now own all that talent in-house. It expands our competitive moat, helps get our cost to where it needs to be, and allows us to scale up with less risk for what we need for our series production launch by the end of next year.
Yeah, great. And Luminar is definitely the most vertically integrated company, and especially amidst the global chip shortage, it's great that you make your own. But something that really separates Luminar from its competitors in the LiDAR space is that the rest really only have one impressive spec. The rest is kind of just noise. And we've seen it, and we've been on pretty much every robotaxi you can name. And the top ones are using Luminar's LiDAR, which is, there's no coincidence about that. But there's a reason that your competitors aren't getting deals with these major OEMs, whereas Luminar is. And that's something that we especially like about Luminar, is that Luminar is not just a sensor company. I mean, you're expecting software to contribute nearly half of the $837 million in revenue forecasted for 2025, even though almost all your current revenue comes from hardware. Can you talk more about Sentinel and then the full stack package? I mean, you're essentially becoming a one-stop shop for automotive safety technologies, right?
And that's the way that we really approach our customer relationships. And when we are in conversations with them, talking about what we're able to do, we really have an a la carte menu approach. And if you want just the LiDAR and you want to do all the software yourself because you have a great team of software engineers that are able to deliver the level of functionality that's required, that's great. We'll give you the hardware, and then the software team can then take everything else that's necessary from the software approach. The next layer on top of that, and I would say one of the first critical components of our Sentinel package is what we call perception software. And the output of the LiDAR is something we call the point cloud. And basically what the LiDAR gets back is a bunch of 3D dots or points of lights. You then need to translate those groups of points from the light into objects. So this group of dots over here is a car 50 meters in front of me. This group of dots is a pedestrian on the side of the road 75 meters away. This group of dots is a black tire on the road at night 250 meters in front of me. You layer onto that also with our perception software, object tracking, where you can get the velocity. Is this object changing its path, its velocity? And so that is the perception software that our team does entirely in-house today. And when we're in discussion with the OEMs, a lot of them, their software engineers are focused more on the robo-taxis and the full stack solution, less on creating perception software from the LiDAR side. And because the data from our LiDAR is so rich, our software is very efficient and requires less compute. So that's the second offering in our, call it a la carte approach. The third, and this is where we actually partnered with Zenseact, which is Volvo's autonomous software arm. So we're working hand in hand with Volvo and Zenseact to develop what is called the full stack offering for the highway autonomy and the proactive safety feature that Volvo will start putting on their vehicles around the end of next year. And once you get the input from the perception software that basically tells you where the objects are in front of you and, doing a good job tracking everything, you're also then going to have the input from the sensors, the other sensors on the vehicle, the camera, the radar, ultrasonic, what have you. You then need to have the vehicle do the decision-making and path planning and basically react. And so this is the brain of the autonomous feature. And so a lot of companies are actually spending billions of dollars to develop this. And you need a lot of software, you need a lot of basically data to train it. You need to build a lot of development vehicles to do this, to get this right? I think everybody who follows the autonomous space, solving the first 99% is easy. It's that last 1%, which is the most difficult. But here, because we're partnering with Volvo, we have the ability to then take that software package and sell it to other automakers. And so if you're a small to mid-size OEM that doesn't have, several hundred software engineers, has not spent years investing in this, but at the same time, you want to get a vehicle on the road with this level of functionality quickly, because Volvo's out there with it and other OEMs are out there with it, you can come to Luminar, and we can not only provide you with the LiDAR, but the perception software and the full stack software, and really sell you a system bundle that is used and approved by Volvo, right? And we all know their safety reputation. They're not going to put anything on the road that they're not comfortable with. And we have the ability to basically deliver that same solution. Now, it's going to be modified for each OEM, but the underlying foundation has been proven to work, and we have the ability to sell that to other automakers as well.
Yeah. Great. There's a lot of noise in the autonomous vehicle space, as I said, especially with all these recent SPACs. Yeah. Luminar is real. I mean, Luminar has been granted more patents than almost all publicly traded LiDAR companies combined. You have over 50 partnerships, 8 of the 10 major global automakers. You have a seasoned team of these industry leaders. You're basically on a hiring spree. Quite recently, Al Prescott, this was a big one. He was Tesla's longtime vice president of legal and acting general counsel until he left Tesla to be Luminar's CLO. He said that he left Tesla for Luminar because Luminar's technology is safety critical and is powering the autonomous future. That was big news. I mean, that right there is telling of where Luminar is versus a company not using LiDAR. Really, the only company not going the LiDAR route is Tesla, who is always the elephant in the room in these kinds of conversations. And I won't get into it, but you can see the shortcomings of its approach in many YouTube videos. Can you tell us more about LiDAR's role in automotive safety? It's not just for robo-taxis, right?
Yes, you're absolutely correct. And a few weeks ago, we unveiled and we shared some videos, and I think the team actually provided the host here a few clips, if they could start to play those now. We unveiled what we call our proactive safety feature here. And if you actually look at all these ADAS systems and these safety enhancements that have been implemented into vehicles over the last 10 years, the reality of the situation is if you measure in the US, the vehicle death rates per mile driven, up until last year, it has effectively been flat. And then last year, even in the midst of the pandemic where miles driven dropped 13%, absolute vehicle deaths increased by 7%. And so vehicle deaths per mile driven increased by over 20%. And so these systems aren't making any real impact on the level of safety out there. And you can actually see in the background here an SUV that's parked right behind my office. And Taylor, if I asked you, based upon just the camera, how far that SUV is, you really can't tell. It's a two-dimensional feature. Now, if I had several cameras pointing at that, and I had you know, an amazingly high level of compute power and a very smart AI intelligence system, and we were actually moving, you could do a lot of calculations by looking how the size of that SUV changed with each frame rate, looking at it from different angles to try to guesstimate how far that vehicle is away. But at the end of the day, it's just an estimate. If you have a LiDAR and had a laser pointer right here, I could know precisely where that vehicle is, how far it's away, and measuring that 10 times a second, get amazingly high level of precision where that object not only is, how far it is away, but where it's tracking and thus where its path is. And so if you looked at the video that the team just played, where you have two cars driving side by side, one with our proactive safety system on it, the other without it, and then you have the child dummy come out into the road. What happens here, because you're guesstimating where the object is, and if the environment in front of you changes quickly, the system doesn't have enough time to precisely estimate how far that object is away. And so that forces the system to basically choose between two things. One is you just can't recognize it in time, car hits the dummy, bad outcome. The other is you can actually build in a high level margin of error where it thinks something could happen, then the vehicle stops. That's going to create a miserable driving experience. And what LiDAR enables, remember, we see 250 meters out in front of us, 120-degree field of view, 30-degree vertical field of view. And so that allows us to know precisely, with a de minimis error rate where everything is in front of us, real-time object tracking, and allows the system to stop when something's going to cross the car's path without having a false positive that creates a miserable driving experience. And that is the heart of why our proactive safety feature, that's why Volvo is standardizing us on every XC90 electric vehicle that they're going to make. The highway autonomy stuff is cool, but the proactive safety feature drives standardization. And here's the beauty of this business model, Taylor, which is the same LiDAR on the vehicle, which enables proactive safety, is the same LiDAR which enables highway autonomy. So if every Volvo XC90 electric SUV has a LiDAR on there with proactive safety as the default, if you want to upgrade to highway autonomy, either at the time you purchase the vehicle or afterwards by electing that option, you can do it with just a software upgrade. And so with OTA or over-the-air features, it gives the OEMs a new value and profit stream where the consumer has actually showed, and I think this is one of the thing that Tesla did very well, which is convincing people to spend a lot of money on a car, but then spend right now $10,000 for the full self-driving feature that is probably a little bit of aggressive naming on their side.
Yep. Wow. Whoop. Yeah, I mean, you guys really take the guesswork out of it. When it comes to safety, I mean, no one wants to be guessing. And also, Tesla even uses your LiDAR on its test vehicles to test for ground truths because it's real, right? Whereas this is not. Just maybe a quick overview of your financials, just so.
Let's get to that, and then we got to wrap it up, guys. So just
okay. Thanks, Spencer. This will be the last question.
Yeah.
So you've raised revenue guidance this year from 25 to 30 to now 30 to 33 million. You're saying you're aiming to be profitable by 2024. In 2025, you expect 90% of that year's nearly $1 billion in revenue to come from existing partnerships, just to give the audience an idea of how significant the current partnerships are. But looking forward, more recently, you've been talking about expanding the business into a subscription model and even getting into insurance. Can you tell us anything more about these businesses and how they may take form in the future?
Sure. And it all goes back to LiDAR is our foundation, right? Amazon started off selling books and then came to dominate the online retail market, and then even expanded into stuff like Amazon Prime. We have LiDAR. We talked about software. We're going to be talking more in the future about insurance and really capturing the safety improvements and how that will drive lower insurance costs, and capturing those savings to subsidize the cost of our technology, rapidly increase its penetration rate, as well as create a new potential value stream for ourselves and our customers. Tesla got into this business. We recently hired the person who set up that business. We're partnering with Swiss Re, the largest global reinsurer. And so that's something we're going to talk a lot more about in the future here, but it's something we're actively working on.
That is a tease. All right. Well, thank you. I appreciate it.
Tom, Taylor, thank you both so much for joining us today at EVCon.